It is 11 o'clock Eastern time, and for the sake of all things supply chain, we're going to stay on time and in full. I'd like to thank everybody for coming to session 2 of our ongoing series. For those of you who are repeat viewers, our last time we talked about managing inventory in a constrained environment. If you were not part of that, please reach out to us. We can get you a link to the recording. We had overwhelming responses to that, so much so that we're really excited to have Erik back again. Today's session, where we'll be talking about the demand-driven operating model. More to that to come. A couple notes here at the beginning. Please follow Demand-Driven Technologies on LinkedIn. We've got continuing blog articles that are coming out. We're getting a lot of interactions with those from customers, from our partners. We love that communication. During the session, everybody's computers, phones, whatever you're logged into, will remain on mute. So please type your questions in the Q&A box at the bottom. We've got a lot of detail to cover today. I promise you your questions will be answered. We'll take them as we can. If we do not get to your question in the session, I promise that we will reach out to you directly afterwards and get that all done. For those that asked the first question just about 100 times, yes, this will be recorded. Yes, it will be sent out afterwards so that you can watch it again in detail. My name is Chris Knapp. I'm Vice President of Sales and Alliances here at Demand-Driven Technologies. Love to hear from you after the presentation. Without further ado, I'm going to pass off to the man of the hour, Erik Bush, to take us through Demand-Driven Operating Model. Erik?
Thanks so much, Chris, and welcome to everyone out there. I really appreciate you taking the time to meet with us today. We're going to be talking about a real critical part of the demand-driven journey called the demand-driven operating model, and we'll get into the details about what that's all about here in the coming slides. There's a lot of content in this topic. Part of it relates to demand-driven MRP. So if you're familiar with that topic and have kind of been down that path, I apologize for a little bit of repetition, but I think it's important to see that context within the overall landscape of what's called the demand-driven operating model, which at a very high level encompasses 2 fundamental philosophies. One is DDMRP for materials management and inventory planning, and then demand-driven capacity scheduling for the production scheduling and execution. And the harmonies between these 2 elements is critical and play a vital role in helping us become more agile and nimble in supporting our own supply chain requirements and the various customer demands that you all are facing out there in the market. So we're going to go rather quickly through a lot of material. It's rather dense, so please use the Q&A feature to raise questions. I'll do my best to make sure there's time at the end to cover all the questions that may come in, but why don't we go ahead and get started here. So we want to talk about why is this so important? And it's really important for a number of critical reasons, but we want to set it in the context of the landscape that I'm sure many of you are living in today. Let's start with what our customers are expecting. And typically this concept of customer tolerance time, which was introduced in the DDMRP education and the like, which is the amount of time that the customer is willing to wait for an order they place with your organization. And in reality, there is a wide disparity in almost all clients between the customer tolerance time and your cumulative lead times. And so we're trying to graphically depict what that looks like down in the lower right hand here, where the gap in red there is the gap between our cumulative lead times, all the dependent events and materials that we need to bring in and the manufacturing to be able to meet that order requirement versus the time that the customer is willing to wait. And customer tolerance times, as we've seen with our clients over the past several years, have continued to get shorter and shorter and shorter, thanks in large part to the global competitive landscape that we're all dealing with, what many call the Amazon effect, that if I order today with Prime, I can have it shipped in the next day or two. So expectations in the market are very, very high. And the problem has been historically, and the real advent of DDMRP was meant to help us address this, was that the longer that time window becomes, the longer that gap between customer tolerance time and our cumulative lead time, the further out we need to be in the future in our forecasting. And obviously, the longer out that horizon becomes, the more we are going to be prone to forecast error. So forecasted demand signals are going to get farther and farther askew of what the actual consumption rates will be in the future, the longer that gap is between customer tolerance time and our cumulative lead time. And then on the same side, the longer that order horizon is, the longer the dependent chain of events to satisfy that customer demand is, the more we can expect to be impacted by variability. Variability in supply, variability in our own production processes, variability in demand, you name it. There will be more demand or more variation accumulating over that longer horizon. And when we juxtapose these two issues, the preponderance of forecast error due to long cumulative lead times, along with execution error or variation due to, the dependent chain of events, we find that we are really in a difficult position, especially in the concept of what's called a VUCA world. VUCA is volatile, uncertain, complex, and ambiguous. It's a catchphrase that's been developed in recent years to capture the challenges that we see facing all of the manufacturers and distributors around the world. Things have been very, very difficult, made more so, obviously, by the COVID pandemic, which while we seem to be getting to a point where it's under greater control and the like, and there's been substantial easing of restrictions and the like, for the most part, most companies are facing some really serious supply chain issues today. And the DDOM model and these concepts can help position your organization to be in a much more adaptive and flexible environment, giving you a greater level of insulation from the aggravations that a VUCA world is going to bring into your environment. So, concepts that are really behind the demand-driven philosophy: position, protect, pull, and adapt. The idea of pull being that we want to pace to actual demand on materials. We want to pace to actual demand on production scheduling and execution. The idea is behind demand-driven is to wait as long as possible before taking actions, because the longer we can do that, the closer we can get to the actual demand requirement from the market, the more accurate our responses will be. And so there's some fundamental elements that we need to put into our model to help us achieve that. And if we're successful in deploying these concepts, we find ourselves in a much more flexible, adaptable environment that is both managing materials to the actual rate of demand in the market, and obviously utilizing production resources in a similar way to do our best to satisfy market demand. So, positioning and protecting. You can think about that as configuring your model, right? Where are we going to hold stock buffers? What are we going to consider drum resources or constraints? Where are the control points we're going to introduce in our model? And by doing that wisely, we put ourselves in a better position to be able to respond to a true pull signal out in the marketplace. And that's obviously, from an execution standpoint, an operational standpoint, the idea that a real demand from the customer, meaning an order, is always going to be a more accurate and cleaner demand signal for us to pace to than a forecast or an estimate of what the demand might be. So if we can position and protect and really shorten our cumulative lead times by proper decoupling and things like that, that horizon gets shorter. We are getting into a more responsive position. Our stock buffers can actually be smaller as a result. So now we're getting into a more responsive position, and that allows us to then utilize a more accurate demand signal, which takes a lot of noise out of the system and gives us greater flexibility. And then the adaptation is about how do we continue to keep this entire model flexible and adaptive and aligned to be able to really adopt the demand-driven philosophy, right? So we need feedback loops that help us further improve our model as we go through time. We also want synchronization and signals going between materials and scheduling and materials to ensure that we've got clear understanding of what true priorities are, as well as what actual, likely status is going to be on promise dates and things like that, because those enable us to do a better job of prioritizing responses that our planners and buyers will take to help ensure that we do the best job we can at on time in full order promise dates. Okay, so there's some key elements here that we're going to talk about. One is decoupling points. Anybody who's kind of embodied or embraced DDMRP in their environment will understand what that means. It's going to be positions in our supply chain where we are breaking dependencies, and those decoupling points help in a number of ways that we'll talk about in the coming slides. Control points. Points are points in our model where we are going to exert control. It could be a pacing resource. It could be a point of convergence in our routing paths. A number of different factors present themselves as good control points. And by identifying these properly, we gain better control of our operating environment and get into a situation where we can have more confidence in our ability to achieve our expected promise dates and the like. Operational buffers. There's some synergy between decoupling points and operational buffers. Operational buffers can be stock buffers, they can be time buffers, they can be capacity buffers. We'll talk about those as we go through, but the idea here is that those buffers are protective mechanisms, helping us to dampen variation, absorb variation, and put ourselves in a more stable operating environment. And then obviously pulling to the actual demand in the market, utilizing the cleanest signal we can find and building an organizational or an operational model through DDOM that'll allow us to respond to that successfully with minimal inventory and the best on time and full fill rate performance. So we'll talk a little bit about decoupling points. Again, we go back and look at this gap between our cumulative lead time and our customer tolerance times. And when we have a wide disparity, we need to see what we can do to break down that barrier or that gap to give us more alignment to what our customer expectations are. If you've been around the DDMRP from content and curriculum, you're familiar with the concept of a bill of material tree, looking at where we may, within the product structure, be able to find some decoupling points through strategic buffering. And there's reasons why we want to do that, because we want to address this gap on forecast variation and error, as well as decoupling some of the execution variation that we may have in terms of the actual production of the overall materials. We know that there is nervousness in our systems. It's well understood and widely accepted that the bullwhip effect is alive and well. We've been kind of living inside the bullwhip as a global population over the past few years, and I think it's going to continue for another couple years probably before we finally get ourselves back to a bit more of a business as usual kind of a standard, if we can even remember what that feels like when we get there. When you think about it, market demand is going to amplify itself if there's variation as we go further down the product structure or further up the supply chain. The bullwhip effect amplifies itself with signal nervousness as it goes through those layers. And at the same time, supply variability and continuity can vary going in the other direction. So what we're trying to do is get better control of these types of variation within our DDOM environment. In fact, I think one of the most critical parts of the demand-driven philosophy is that we shift our attention from being all about the forecast to being all about understanding how variation occurs and what influence it has on our operating model. And in point of fact, we can get far better control if we understand variation to a greater degree. How much material movements are going to vary based on the variability of the demand signal that they experience, how much supply variability we have, either from our external suppliers or even with our own production operations environment. The more we control those, the more stability we bring into our operating environment. And that picture of the bimodal distribution of materials, which is so classically found in every client that we meet with at the beginning of our journey with them, indicates that they have, too much of the wrong stuff, too little of the right stuff. That means if those are finished goods on the wrong side of this picture here, it means we use production resources for things that weren't selling. And for the items that are on the left side, it means that we maybe didn't have materials, or we didn't dedicate production time to ensuring that those materials are available. And what we're obviously looking for is a nice bell curve where the vast majority of our items are in that optimal range in the green zone in the middle of this picture. This variation is going to occur not only within our walls, but it's going to occur across our supply chain. Can't tell you how many clients we've talked to who are lamenting that, through the COVID pandemic, the supplier lead times that they're dealing with have extended to extreme levels. We tried to deal with that in the managing in a supply chain constrained environment in the last webinar. And if you weren't able to attend that one, I encourage you to follow the links available to get to that content, because it will help you with those environments as well. So decoupling is about breaking lines of dependence, right? Creating independence between those. So if we can create points of independence, what we find is that we create breaking points that help dampen the level of variation that cascades through our supply chain. This is a concept that's been in the APICS dictionary for quite a while, not really well utilized in a traditional MRP environment, but clearly one of the fundamental tenets of DDMRP. By creating that independence between those 2 points, whether it's within the product structure or layers of the supply chain, we start to dampen variation and we gain better control. Firewalls are a type of decoupling, bulkheads and ships. These constructs are familiar in industry and in our daily life, and yet in our planning systems to date, we've not really been able to take good use of them in the manner that both DDMRP and DDOM can help us accomplish. Decoupling inventory is about finding those points where within our product structure, we can create some independence between the layers of steps within the bill of material. So if you've been in the DDMRP world, you understand what a DDMRP buffer is, a stock buffer, a replenishment buffer. The concept behind those devices, if you will, those decoupling points, is the idea that by buffering correctly, the material will always be available. And that's the going in assumption. If we know the material is going to be available, then those upstream elements of its lead time, the supplier lead time coming in for purchase items as an example, no longer needs to play such a dominant role in our cumulative lead time. So we talk a lot about decoupling lead times, compressing them. We've had clients that have gone from 50-day frozen periods down to 9 days. And obviously, the more compression you can achieve, the more agile and nimble you're making your organization, and the less risk you are to that issue of forecast error that we talked to at the beginning of the slides. So it's about finding where do we do them and what's so different about decoupling from the standpoint of safety stock. Where we've introduced decoupling points now at various points, a couple sub-assemblies. Over here, we haven't necessarily put one at the finished product, but we could do that as well, and we're gaining some further control. This will help us get our materials aligned to where they ought to be, to what true market demand is going to be. Items that are not decoupled can be ordered on a normal, traditional buy-to-order kind of standpoint or make-to-order kind of standpoint, typically because their lead times are low enough or short enough that they're not adding to that cumulative lead time to any severe degree. This creates a point of independence, and if SAD or SAC are components that are used in other final assemblies, then obviously we're not only going to gain leverage on the lead time of this parent item FPA, but any other parents that these subassemblies may go into. So it's got a strategic element to it as well, not just at a product level, but perhaps in product categories and the like. And we can obviously do this too within the layers of our supply chain, buffering key parts for components coming into us, or if we have some vertical integration within our business and are operating across multiple sites, as many of our clients are, where one division is feeding another, we can create independence, allowing for both sides of the operation to gain a benefit in that regard. So where do we decouple? How do we determine this? There's a lot of techniques you can utilize. You're obviously looking for items that have heavy levels of recurring usage. that really do help us break the lead time horizons that are going to have an impact on that cumulative lead time that we were talking about earlier. So you're going to be looking into your product structure to understand where those opportunities are. We have to then understand, how do we size the protection? Again, the idea is we want to have constant availability. That's what achieves the decoupling level that we're looking at. So we're going to ensure that we understand the variation, the rate of demand, obviously the lead time for resupplying a given item that we're trying to decouple. And we can calculate these, we can get into this in much more detail in a normal DDMRP webinar, but this is how we're applying things like AI and machine learning to help bring even more intelligence to this level. And then obviously in an adaptive enterprise, we're going to maintain vigilance around this to ensure that the settings that we have in place to ensure that that decoupling is working for us continue to support the types of demand patterns that we're seeing out in the marketplace. Okay, factors to be thinking about. What is the customer tolerance time? How much do we need to compress that cumulative lead time to give us the most responsive environment we can be in? There may also be opportunities to expand our market. In other words, if we can shorten our response to the market, say from 10 or 15 days down to 5, how much additional revenue will that drive for us? Because buyers are very much in that point of wanting greater and greater flexibility. And so market potential lead time really is indicative of how much additional revenue we could drive if we were able to further decouple. What is our sales order visibility? How much of an order book do we actually have in place? In most clients, it's gotten shorter and shorter over time. They may have a long-term forecast from a vendor or from a customer, but in reality, they're only committing to that which is in a frozen lead time or a frozen horizon, a very short window. So we need to understand what that picture looks like. How much variation do we encounter? Are there places within our matrix bill of material that we can get strategic leverage out of decoupling where we have shared intermediate components and the like? And then also, and this gets us over to the scheduling and execution side, are there operational areas within our business, meaning production areas, where we want to protect those resources through having stock available so that they don't run dry and limit the amount of output of the entire system? So now let's shift our gears. Let's go over more towards the operational side and the execution and talk about control points. These are points within the product structure, and as you'll see, the DDI really thinks about it more in the context of routings or activities, where we can simplify planning, scheduling, and control functions. These can include gating operations, points of convergence or divergence. They can include your production constraints, and obviously your shipping points, and relate to how well you're able to make your on-time and full order fill rate performance. And if you think about control versus decoupling, there's a relationship here. Control points are placed at the routing level, right? So we think about a bill of material view, we know the components that go into a final assembly. When we think about it from a production standpoint, there will be production steps between those various layers in the bill of material that need to be performed and understood. And that may illustrate where there may be points along this path where we want to introduce incremental control to help us. The decoupling creates points of independence. Obviously, if we're buffering some of these intermediate components, their schedule and their production schedule is going to be dictated by when that buffer needs replenishment, while as the remaining assembly steps, in this case, the label, print, paint, and prep, would be the remaining execution steps that we need to be worried about if these are the components we're bringing in. PPA at the bottom here is a purchased item that then gets transformed into ICA, which then gets changed into our FPE product at the end of the day. We want to be able to control, and this means about pacing the release of material into the plant. This means about setting the production schedule and the load against all the various resources in that environment. We'll talk a little bit more about that here in the presentation, and then in our next webinar, we'll show you how our software can help you accomplish that systematically as well. The boundaries are kind of the defined by the decoupling points. So this is an operational boundary here, because these are the only process steps that we need to go through to get to ICA and its structure. So let's talk also about entry and exit points. Obviously, we know entry points. This is where supplied materials come in from the outside world, whether they're onshore or offshore suppliers. That's a point of entry into our production process. And normally when we're thinking about it, we're thinking about our operational environment is within these walls of where material comes in from the outside world and where it leaves us to go out to, from a transportation standpoint, to the market, to the end customer, if you will. And that's kind of the horizon that we want to be focused on when we think about our DDOM model. And if we can control these entry and exit points well, then obviously we can help stabilize operations within those boundaries in a much, much better way. All right, so let's talk about pacing resources. There is no confusion about the fact that demand-driven capacity scheduling is heavily driven off the drum buffer rope concepts of the theory of constraints. Chad and Carol of the Demand-Driven Institute were all colleagues of Ellie Goldratt during their careers. They were not robbing and pilfering TOC, they were building on TOC in creating the demand-driven concepts that we're presenting here today. But if you've been through the TOC literature, if you've read the book The Goal, you're familiar with the idea of drum buffer rope, the idea that there are pacing resources that will determine the total system's output. And understanding what those are in our environment and how best to manage them will go a long way towards helping us stabilize operations and getting the best output for the system. And obviously we've got the tortoise and hare analogy here. The rabbits are the ones that can run much more quickly than the drum, which is going to be the tortoise, and has a slower rate of production and is typically the bottleneck or the constraint defining how much throughput we can get through this system. And it's always important to remember that time lost to the constraint is time lost to the entire plan, right? So when we have these interdependencies, we really need to be cognizant of the fact that if we lose time on that constraint, if we misuse that resource, we are going to suffer a bigger consequence because it's going to affect the output of the entire system. And it also helps us start to think about these rabbits. We're going to call them capacity buffers in a few minutes. But the idea is that if we have variation in our operational process, we don't want to be in a position where everything is level loaded, because that basically takes away our flexibility to respond to whatever variation occurs. If it's downstream of the drum, it may be to catch up because there was an issue on the drum resource, and we want to be able to catch up for lost time. If it's upstream of the drum, we obviously don't want to lose time on the drum because there's variation. So we want to think about capacity buffers, which we'll talk about here in a few minutes. Okay, common points. Common points are points within our production flow where things converge and they have a common relationship to the end products. They could be a point of convergence, could be a point where things diverge as well. These common points are important to understand in your production environment as well, because they may illuminate themselves to be places where we can introduce some better control into our environment and gain some advantage from that. Because obviously it can control multiple paths, and that's kind of the whole philosophy behind the common points. Great examples here: paint lines, quality control. You know, we've got clients that are painting everything one color at the end before some maybe final assembly and packaging steps, because that's their branding and the like. So oftentimes that paint line may become one of the constraints that we need to be paying attention to. Quality or control or test centers oftentimes play that role, because many times test centers can be configured differently for different end items and the like. So in each of your own environments, I'm sure you've got some examples of this that could become good candidates to be control points or common points in your environment. Obviously, unstable resources. You know, we think about these and, you know, it could be that there's an aged machine that has poor reliability that we're dealing with. Those can be candidates. It could be a process that has a great deal of process variation. For example, in lens manufacture or in circuit board manufacture, sometimes they don't grade out as well in test, and we don't really know what we're getting until we run the production job and we understand what the actual outcomes were. Maybe we have 3 or 4 gradients and we can take the downstream product from that in different directions. But obviously, if we have instability, those resources become good control points because it will intensify our focus, try to gain through process of continuous improvement, better control, bring those within the control limits so that they are less impactful to especially the downstream resources. Anybody who's dealing with this knows these problems. They're very, very difficult to manage. But obviously, one of the key tenets as well from theory of constraint is we want to find the points of focus. It's better to find the few things that really matter than it is to try to focus on fixing everything, because oftentimes we spend time on things that are far less critical to overall success than the few that really do matter. Okay, so now we're going to talk about operational buffering, and there's 3 types of buffers that we're going to talk about. We've talked about stock buffers from a DDMRP standpoint, so I'm not going to spend too much time on those. Those are at the product structure level or within layers of the supply chain. They gain us independence within wherever they're placed. They gain us a reduction in variation cascading through our environment. They ensure constant availability of materials, and they also provide clear and visible signals from a material planning standpoint, enabling planners and buyers to focus their time and attention in the right way. In a similar fashion, on the scheduling and execution side, we have time and capacity buffers. Time buffers are time inserted into the routing. There will always be time buffers put in front of a drum resource. From a DBR standpoint, that's what drum buffer rope means. Buffer is that time we're inserting in front of the drum to ensure that that drum resource is never left waiting for work to come through. And they're there to protect against upstream variation. So we'll see about examples where we're going to have time buffers in front of our drum resources, as well as at the shipping level to help protect our on-time order fill rates and the like. Capacity buffers have to do with kind of the rabbits that we talked about earlier, or the hare and the tortoise and hare analogy, where we want to have enough sprint capacity to help compensate for whatever variation occurs in our environment. Now, from a lean standpoint, lean kind of with Hijunka and planning and all this is trying to stabilize operations where every resource is running at the same rate. And that's, I think, a very interesting idea. And where it works really well. And you can think about an automotive assembly plant where the whole production process has been organized and deployed in such a way that every process step is operating at a similar rate of production and flow. The assembly line itself helps create that pace of activity and the like. And so obviously through lean, you can stamp out variation within that kind of controlled environment, but oftentimes there's still variation either upstream or downstream of that plant environment. And so the idea of level loading is kind of a bit counter to what we're trying to do in DDOM, where we accept that variation is going to be occurring. And so we want to ensure that we've enabled ourselves with enough sprint capacity to make up for lost time should we have variation impact us. It's another form of protection. It's not really popular with the finance guys because they think every machine should be running all the time to get the lowest cost per unit produced. But as we all know, that can have a dark side as well by introducing too much work in process that becomes part of that too much of the wrong thing issue when we just load up machines to get work done on the basis that we're hoping that it's ultimately going to sell. So we're going to look at that a little bit differently here in a few slides and give you some different thoughts around how you manage capacity buffers. Stock buffers help protect against penetration and give us that constant availability. Time buffers help us compensate for the delays that may accumulate upstream of given process step. And capacity buffers are there to help us compensate for the different loads that may be required, either due to variation or changes in workload mix and things like that. I'm not going to go through this one because I think most of you have probably understood DDMRP buffers, but these are the basic dimensions that influence the size of a buffer for a given stocked item. And they're based on the inputs of rate of usage and lead time factors and things like that. So in the interest of time, I'm just going to skip over this. If you have more questions about DDMRP, just let us know and we can cover that off in a separate call. Time buffers, though, this is really important because it's about how we're going to protect ourselves. Again, the drum resource is limiting the pace of output of the entire process, right? So they're dealing with whatever variation we're going to have. Obviously, if this is a prep step and it is the drum because it takes a long time to get it done correctly, we want to make sure that we are loading this activity in a proper way so that the overall flow is maximized through the whole process and is in a position to be able to absorb whatever variation. So the time buffer that we're going to insert here is going to protect for variation in these upstream steps, where this is like a metal forming environment where we're cutting, we're forming, we're doing some grinding, then it's going to prep, paint, label, and ship, right? So obviously, everyone's production processes are going to be a bit different. But the idea here of inserting a time buffer is to ensure that we're able to maximize our output on that drum resource. The time buffer here just before shipping is there to ensure that we can ship on time and meet our delivery requirements out to the marketplace. So time buffers are meant to produce the effect that the work is ready for activity when it's needed, right? So there is a schedule for the drum resource. Each work order should arrive at a certain point in time and be ready to go into that production step. And we want to monitor the pace and the arrival of those work orders so that they arrive at the appropriate point in time. If they arrive late, then the risk here is that we will lose production time on that drum resource. If they arrive too early, that's also bad because now it's going to introduce work in process, clutter up the floor, and creates confusing signals for shop floor operators to understand what really needs to be focused on. So we want to use the time buffer to monitor the incoming work orders to ensure that those orders are being managed through their upstream routing steps in a proper way. And that visibility helps with shop floor expediting, monitoring, and the like. Because if items are going to come late, then maybe we have to change the schedule at the drum resource and we don't lose time on that drum, which obviously we know has a very negative impact. So part of the process here in DDOM is not just about scheduling, it's about shop floor execution and having proper visibility to understand where do we need to take interventions to help ensure that we don't lose time on our drum resources. So time buffers play that benefit. They give us time to absorb variation from upstream routing steps. Can be critically important, obviously, if you have highly variable manufacturing activities within your routings. Capacity buffers have to do with managing delay that accumulates through the routing process. Because if we have variation in these upstream process steps, then they are going to result more likely than not in us penetrating this time buffer and potentially arriving at the drum resource too late. So we want to create insulation so that that doesn't happen. And if we have sprint capacity or capacity buffers, then if there are issues of upstream variation, we're going to be in a better position to catch up because we have more capable run rates that would allow us to ensure that we've made up for lost time if needed. And then on the downstream side, those are going to protect our ability to keep our stock buffers full or to be able to ship on time for make to order items, which will have a time buffer in front of them. Now, obviously, and very consistent with the lean philosophy, the more we can stamp out variation, the more we gain control of our environment, the smaller these buffers can be, right? If we're in a client that's really got a lot of operational challenges, the time buffers are going to be rather heavy. And then what that's going to help them do is to understand where to focus their time and attention to bring those issues of variation under greater control. Lean is all about eliminating waste, eliminating variation. So if you're in a very healthy, lean environment, you've probably reduced a lot of this variation coming through, and your time buffers would by definition be smaller as a result. If you have a lot of variation, then obviously you're going to need healthier buffers. Again, the idea being that we want to make our promise dates on a reliable basis. We want to improve our on-time and full order fill rates from, maybe in the 70 to 80% range up to the very upper ends of the 90s. So we've got the idea that we understand that there's disparate levels of capacity. And so if we can understand load against the actual capacity and have visibility to that, then we can understand where we may need to make changes. In this case, item C is probably going to be our drum resource because it's got a capacity limitation unequal to what the actual load would be. And so we're going to have to finitely schedule that, but we would want the upstream and downstream resources to have a little bit extra bandwidth to be able to support that idea of catch-up time should there be issues with variation within our process that we haven't been able to bring under control. So you can think about the capacity buffer as the gap between the load and the amount of capacity a resource has. And the more of this you have, the better, obviously. Some would say, well, there's a limit to that because then obviously we're maybe using some of our resources inefficiently. We understand that. But not having any capacity buffers can be very, very detrimental to your production process. So think of it as non-required capacity. It can be used in a number of different ways. One is to obviously catch up and address variation. Maybe we have an expedite or we've got a breakdown in one of the machines in the routing step. If it's stable and we see that we continually have that excess capacity, maybe there's opportunities where we can exploit it. We can utilize that to create other products or materials that can be useful in the market, or maybe we can convert items that we're buying from the supplier community now that we could be producing internally through having our own capability. Or it could be the idea of labor shifting. If we have skilled labor and we have changes in our rates of demand, maybe we want to cross-train and have people who can flex to a variety of different environments to give us more flexibility within our plant to be able to get the work done in the manner needed for the market. So we can think about it in this fashion. The closer we are to the capacity, the more we are in the red zone, right? So the more we have available capacity, the better off we will be. And this is going to be in stark contrast, as you'll see, to the concept that typically we look at it from a financial standpoint. So, we're in the red if we're right near the capacity limits of a given item. We're in green if we're well below that, if it's a capacity buffer. If it's in an overcapacity, it's likely going to be considered as a constraint and would be managed in a different way through time buffers and finite scheduling. And this is kind of the way the workload would look over the days in the week. We would expect some days might be getting up and stressing the system a bit, but overall we should be down in the green zone or dipping into the yellow zone on occasion. And this is very much in contrast now. This is a flow-centric, demand-driven kind of way. Make sure we've got capacity available to a cost-centric way of thinking where the idea is any time lost to any resource is lost profitability. And in point of fact, that's absolutely not the case. So we want to try and help people understand within the organization that it's a good thing to have sprint capacity. It's not a failure to be profitable. It's actually going to help us ensure that we service the market more reliably, which will lead to more revenue growth and more overall profitability on a longer term basis. So when you think about it, fully configured DDOM, we've got stock buffers at various entry points here from suppliers, a supplier that comes in further down the routing path. We've got a stock buffer to help ensure that we've got availability for make to stock items. We've got time buffers for make to order items, protecting our ability to ship on time. And then we've got time buffers being used here to protect that drum schedule. The capacity buffers really reflect having additional sprint capacity in the other areas of the production flow to ensure that we don't encumber the drum and run it dry of work to focus on, and that also, help us achieve any catch-up if needed downstream of a drum resource to make sure that we can make our promised dates to the marketplace. Okay, so a lot to absorb here. We think about stock buffers helping us have better supply or management strategy for managing supplier variation, to decoupling our lead times with intermediate components and obviously the bought-in components, and then on make-to-stock items to be able to service the market on demand, in essence, by pacing to the actual demand in the market. The time and capacity buffers are really there to help us bring these other elements together. And when we fuse these together into a DDOM environment, we get some very interesting signal now. DDMRP is our material generation, supply order generation, but it's also going to help us understand signals that we need to send over, to scheduling, for example. Here's the orders that we need to generate, and the status of our buffers and the orders that we're actually responding to can be used to prioritize our scheduling environment. The demand-driven execution relates to, expediting inbound materials, seeing execution alerts such as material synchronization alerts where a work order is behind the request date for a given item on a non-buffered or make-to-order item, and we want to see if we can adjust that schedule. Or we are exposing our stock buffer on a make-to-stock item, and we want to prioritize work orders related to that so that they get better focus. The feedback coming back from scheduling will then also help us see those alerts in more detail, because manufacturing orders will have promise dates attached to them. Those may not align perfectly to the request dates of the client's orders, and there may be the ability to expedite, adjust, make changes in our scheduling algorithm to help improve our overall fit of those orders. Our on-hand inventory levels, our buffer statuses can then help synchronize and ensure that we're providing the best supply order generation, recognizing what our capacity scheduling is capable of, and bringing these two sides in harmony. DDMRP on its own is a great method, and it gives you a sense of priorities from a production standpoint, but it's not as complete as what you'll gain once you shift to a DDOM environment. So there's a lot more we're going to get into on this. We'll talk about this in more detail if you come to our next webinar in the following month. But I'm hoping that you can kind of get a sense of how in a DDOM environment, we kind of round out the story from an execution horizon standpoint. We know how to bring in materials into our environment properly. We know how to pace to actual market demand. We also can align our production resources in such a manner that they help us achieve those promised dates to the market, be they make to stock items or make to order items. They also share kind of the buffer status, material availability checks and the like in a fashion that allows us to really bring these two elements together in a very healthy way. We have a number of clients that are operating in this environment today and getting great synergy from bringing both sides of the DDOM model together. So with that, I want to thank the Demand Driven Institute for allowing us to utilize this content. This is their copyrighted material, but I've had the privilege as an affiliate of the DDI to be able to use this as introducing these concepts. You can obviously learn a lot more about demand-driven operating model, the demand-driven adaptive enterprise, DDMRP, all the education and curriculum they've provided. They've done a phenomenal job introducing these concepts out into the world. And I really encourage you, if you're not already engaged with them, to get to their website, look up the information. It's amazing to see how much this movement has grown over the past several years. And we've obviously been very proud to be part of that journey. So I'm checking my clock here. It looks like we left a few minutes, so that's good. I know I went very quickly through a lot of material here, so eager to take any questions that you may have. So Chris, do we have any questions to answer?
We do, Eric. I appreciate it. Obviously, to reiterate what you said, a lot of fantastic content. I know you, the entire team here at Demand Driven Technologies and the Demand Driven Institute would be happy to speak with further. But a couple of questions that come in to Eric. In terms of capacity buffers, can supplier capacity be considered as well?
Yeah, absolutely. This is more of a software question, but if you attended the Managing a Supply Constrained Environment, most of our companies that we are working with are dealing with this in some level. And obviously the big automotives have been facing this with the chip crisis and the like. But yes, absolutely. And we encourage clients to do that. It requires a deep level of collaboration with your vendors. What you're going to want to understand is the rate of supply that they can provide. it may be below your production capability. And if that's the case, then that supplier capacity may need to be considered as a constraint and finitely scheduled and dictate the schedule of the rest of the production, because obviously you don't want to be kicking off work orders that you don't have enough materials for. So we would absolutely encourage clients to think about how they can model that. It's more about what is the rate of supply that a supplier can bring into the environment on an ongoing basis. It may be, one order of 5,000 every month, but that converts over 4 weeks into whatever that is, 1,250 units a month or a week or something like that. So, but yeah, if you can get onto that level of discussion with your vendors, you should absolutely be able to do that.
Great answer. We've seen a tremendous number of participants. I know some folks have been coming and going. You may have answered a little bit of this, but is lean compatible with the demand-driven operating model?
Absolutely. There are some ideological, conflicts out there at times, but I think lean and DDOM are very, very, very compatible. Lean, the way I think about it, is really about driving out waste, reducing variation. All of those things are very, very compatible. And so lean Kanban loops from a material supplier, very similar to DDMRP buffers. The idea of level loading, might be one from a Hijunka standpoint, is it's more a matter of how do you apply it and the like. But the idea of DDOM is to make sure that you reserve enough sprint capacity. I don't think that's not consistent with lean and how that scheduling methodology works. But you have to understand that there will be variation, and if you can drive it out of the environment, great. Then you don't maybe need as much in the way of capacity buffering as we might in other environments that are not as deep down the lean path. But I think they're very synergistic with each other, Chris. A well-run lean organization should be able to get good benefit out of DDOM as well.
That's great. And I think you kind of answered a little bit of this question, but let me make sure that we ask it so that you can address it. My company has strived to achieve level loading across production resources. DDOM advocates for sprint capacity. Which approach should we follow?
I think, as I said, they're compatible. I would say the answer to the question I can't answer, yes or no, is going to depend a lot about how much variation you still are managing in that environment. So that question is really one of those. It kind of depends. I hate to say that, but it really does. If I still have a lot of variability in certain production rates within that environment, whether it's machine breakdowns, labor availability, processes that are by nature hard to control or hard to gain the proper yields from, you're probably going to still need capacity buffers. So, yes, you should absolutely try to drive out those levels of variation, but if they're still there, then the idea of capacity buffers can be quite useful. Maybe a hybrid environment might be more appropriate in that kind of an environment.
All right. The excellent questions out there here. Let me, there's a couple more, Eric.
Okay.
Our suppliers have increased their lead times on key materials. Boy, this is a pretty poignant one since COVID, huh? Our suppliers have increased their lead times on key materials. How can DDOM help address this?
Multifaceted answer on this one. Supplier lead times are always a big factor. The decoupling of long lead times can have a big impact. Go back to that first chart where we talked about the difference between customer tolerance time and cumulative lead time. So if a supplier is stretching out their lead times to whatever extent you can achieve a stock buffer that absorbs that level of lead time increase, it will help you dramatically insulate yourselves from those lead time issues. I think the other side of that, though, is that oftentimes what we've seen is that the reason that lead time is increasing is that the supplier is behind on their own past due demand, meaning that they haven't, for their own reasons of their own supply constraints, for example, not been able to keep up with the market. And so they've got this growing backlog of demand And we kind of pointed this one out in the supply constrained environment webinar. Because they have their own backlog of demand, they're behind, and so they can't commit on their normal lead times. So they're extending their lead times because of their own issues. So I think it's two-faceted. One is do everything you can to buffer and absorb that lead time change because it will give you more responsiveness to your own market. But then secondly, if it's because of their own supply constraints, then you're probably living in the the world of the other webinar that we just did, and ought to be thinking about how within your DDOM, then you model their supply constraint to you as part of your environment from a DDOM standpoint. You know, put time buffers in front of it, capacity constrain it so that it doesn't drive you, so that by doing that, you limit the rate of purchase of other non-constrained items and things like that. So yes, absolutely, DDOM can help with that. A number of different tactics depending on the circumstance.
Excellent. Got a new question in from Kevin. Erik, what's your suggestion to let the management level change their idea from the cost view to the flow view, and then see the power of DDMRP, DDOM? Thank you. That's a big one.
There is very good content from the DDI. There is a book out around smart metrics that helps illuminate some of these topics that I would encourage you to take a look at. I think a lot of it goes to understanding your own market and the ability to improve your on-time order fill rates. This to me is the high ground for supply chains these days, is if you become known as the reliable vendor that can, you know, deliver on time consistently, you are going to own your market. And I just look at what Amazon has done. It's just amazing to me how effective they've deployed this concept, and they have such a dominant position. It's incredible. But I think every company can exert that kind of strategy. And obviously with increased order fill rates, your prices can be a bit higher, your margins can get better. So there's a little bit of connective tissue between how I change my production environment and how I operate a DDOM to getting those results. And that's where the smart metrics can help with. But obviously we can help with clients if they've got interest in having those discussions as well. But the answer, it's a weak answer. I should be able to give you a formula, but no, it's all about achieving better on-time order fill rates, gaining a leading position in your market, and reaping the rewards accordingly.
Excellent. I see one last one here. Unless to everybody out in the audience, please type in any remaining questions here. But the last one I see, familiar with inventory buffer. So how do you size time buffers?
Great question. It's all about variation. And variation is going to be typically related to the sequence of events leading up to that time buffer. So in other words, if I have a routing that has one step between the release of the work order and the drum resource, I should expect to have much lower variation. And I should be able to, we gain information about this. We'll talk about this when we do the software demonstration in the next webinar. But we can gain understanding of what was the actual cycle time for that step in the routing, in that one step in that routing that had the one step before the drum. If I have a long series of steps, then obviously there's more risk of failure and more risk of variation. So the real answer to the question relates to understanding what our work order history has been, understanding the rates of variation, the transaction activity that we gather in our Intuiflow scheduling and execution allows you to capture that. And then you start to dial in what those time buffers need to be. Time buffers in our environment are not one size fits all. They're tailored to the complexity of the routing and the variation that's incurred in those routings. We do have kind of families of these time buffers based on different categories of routing complexity and the like. But they're typically, you're going to look at what is the level of variation we're incurring, where do we think is the kind of right level, and we'll set our time buffers based on that kind of insight. kind of the way we do on stock buffers, where we look at the rates of actual demand variation or supply variation and helping set those up.
Thank you very much, Eric. With that, folks, everybody, it is 12 o'clock Eastern, no matter where you're at in the world, whether you are a partner of ours, a customer, a prospect, or just someone interested in the greater community and hearing more about some of these fantastic supply chain methodologies, concepts. Thank you so much for taking your time with us today. Eric, I'd like to thank you as well. Do you have any other final comments before we conclude?
Just wish everybody the best on their demand-driven journey. Stay safe and healthy.
Thank you, everyone. Please follow us on LinkedIn. Our next webinar session will be September 14th on scheduling execution. Take care, friends.
Thanks, everybody.